Pogo pins and spring-loaded connectors. These are widely used for spring contact, charging contact, and modular interfaces. Some variants include solder connections, supporting semi-permanent integration into fixtures or assemblies. High current test probes. When higher currents are involved, power electronics, battery testing, or high current rails, special probes handle higher ampacity while limiting heating, contact wear, and measurement instability. Pneumatic test probes. Pneumatic actuation can help when a controlled approach and consistent force application are essential. These probes are often used when a test setup requires high repeatability or specific mechanical sequences. Interface pins and interface test probes, plus fixture customizing. In real factories, probes rarely live alone. They are integrated into adapters, interfaces, and fixtures. Interface pins and interface probes support different adapter standards and allow engineers to build reliable test hardware. Fixture customization becomes a key step to align the probe technology with production constraints. Why probe choice is a strategic decision. Probe selection is not simply pick a length and a diameter. It is an engineering decision influenced by pitch and access constraints, tip geometry and surface condition, required spring force and mechanical life, current and frequency requirements, fixture design and alignment tolerances, maintenance cadence, and replacement strategy. A good choice reduces false failures and keeps test results trustworthy over time. A poor choice turns test into a bottleneck.